So I'm going to show you how to get from an equation like this to a graph. But before I do, I just want to pause for a moment and ponder this question. What are some pairs of x and y that make this equation true? Can you think of some numbers that I can put in for x and y, that I can substitute for x and y, that will result in a true equation? So I just want you to pause and have a think about that. Can you think of a way to fill in the x and y here to make a true equation? Now, I hope you actually did that because you'll get more value out of it if you do. What I hope is that you came up with something different to me. And in fact, there are many different pairs of x and y that make this equation true. One of them, for example, maybe x is 0 and y is negative 2. 0 take 2 is negative 2. Y is negative 2. That would be a true equation. Maybe x is 1 and y is negative 1. Probably here's an easier one to think about. Maybe x is 3 and y is 1. If I put those in the equation where x is 3, so that would be 3 take 2, and y is 1, then this says 1 equals 3 take 2, which is true. That's a true equation. So you can see that we've got a few pairs of coordinates here that make this equation true. We can plot them. We can plot them on a Cartesian plane. This point, 0, negative 2, x is 0, and we go down 2 because y is negative 2. And then if x is 1, y is negative 1. So we'll plot x being 1 and y being negative 1 over there. And x being 2 and y being 0. And x being 3 and y being 1. And what we notice is that this seems to make a straight line. So we can draw the straight line, and it's common practice to put arrows on it as well to show that this line actually goes on forever in both directions. There are infinitely many points that make this equation true. And if you plot all of these points, all of these infinitely many points, then you'll see that they all lie on this straight line. And in fact, that's what a graph of an equation is. It's the set of all x, y coordinates, the set of all points that make the equation true. And you can draw the graph by drawing those coordinates, those points, on a Cartesian plane. So that's what this video is about, getting from something like an equation into a graph of the equation. Now, suppose that we have an equation. I'm going to pick on y equals 2x plus 1 as an equation. It's easier to understand the equation if we can draw its graph. One way to draw its graph is to make a table of values, which is what we're about to do. It's like an experiment where we substitute different values for x and we look at what happens to y. Let's see how it works. So we're asked here to make a table of values for x being negative 2, negative 1, 0, 1, and 2. So we're going to explore x being each of these 5 different values. And for each of them, we're just going to see what happens. So let's try it's tempting maybe if we want to try these one at a time to start with negative 2. But I'm going to choose to start with 2. I want you to pause, have a little think. Why do you think I'm choosing not to start with x being negative 2? The reason is that it's a negative number, and negative numbers are harder. Let's start with something easier. Let's imagine a world if x equals 2. Imagine that x equals 2. If x is 2, then what would happen? Well, first, let's copy down the equation that we know is true. Y equals 2x plus 1. We know it's true because we're told it's true. And now let's replace x with 2. We're imagining a world where x is 2. So I'm going to substitute, which means to replace x with 2. So we'll write this equation again, but instead of x, we will write 2. Now you might notice that I've done something funny. This looks like it says 22, but it shouldn't be. There should be something in the middle here. 2x means 2 times x. And if I write it like this, It looks like the number 22. Let's put 2 times 2. I like to call it between a number and a letter, there's an invisible times sign. And when you substitute, you need to put that times sign in, otherwise it looks like 22, when really it's 2 times 2, 2 times x. Okay, so I've substituted, replaced x with 2. So y is this thing. Now 2 times 2, I can figure that out, is 4 plus 1 is 5. Notice that I use BEDMAS. I do the multiplying before I do the adding. Cool, so that's the answer. If x is 2, then y would be 5. So in a world where x is 2, y would be 5. We can repeat this process for each of the other x values. Imagine a world where x is 1. Well, we write the formula. Notice that because we're doing this a few times and it's a bit tedious, I'm taking a shortcut for this one and all of the other ones. I'm not going to write the equation first. So much like this, the equation says 2 times x plus 1. Here, x is 1, so it's 2 times 1 plus 1. X is 1 in this world. And again, I can replace 2 times 1 is 2, plus 1 is 3. So if x is 1, y would be 3. And we can repeat for the other ones. If x is 0, y is 2 times 0 plus 1. I need to do the multiplying first. 2 times 0 is 0. 0 plus 1 is 1. 1. And if x is negative 1, a little bit trickier because it is negative. Y is 2 times x plus 1. X is negative 1, so it's 2 times negative 1 plus 1. This thing here, this 2 times negative 1, to figure out, to multiply positive and negative numbers, first, think of the sign. I've got a positive and a negative. Positive and a negative make a negative. 2 times 1 is 2. So I've got negative 2. So I like to think of the sign, positive, negative, and the number separately. This bit I can just copy down, plus 1. Now I've got negative 2, add 1, which is negative 1. If you're not sure about that, I'd suggest doing a number line. We'll help you out. And finally, if x is negative 2, then we can figure out what y should be. Now for each of these values of x, I've figured out what y would be if that was the case. Okay, but why? Well, now that we've got a table of values, we can visualize it. We can see what this equation looks like. And to do that, I'd suggest drawing a Cartesian plane. You know, you've got your vertical and horizontal line for your y-axis and your x-axis. You've got your arrows at the end. You've got your tick marks. These little lines are the tick marks. You've got your numbers for positive and negative. We label x and y axes. And now we can start plotting these points. This point here, x is negative 2, y is negative 3. So the x is negative, so I'm going to go to the left 2 units, and y is negative 3, so I'll go down 1, 2, 3 units. Put a dot there. The next point, negative 1, x is negative 1, so left 1 unit, y is negative 1, so down 1 unit. The next point, x is 0, so I'm not going to move left or right. I'll stay just here. And y is 1, positive 1, so I'll go up 1 unit. And so on. x1, y3 is right here. And if x is 2, y is 5. So x being 2, y being 5 is right here. And once I've drawn these points, I can see that they lie on a line. So, and I'll put a little arrow to show that this line goes on forever. This is the graph of that equation. It's the graph of the equation y equals, what was it? I'll have to go by memory. I think it was 2x minus 1. Oh no, it was 2x plus 1, wasn't it? There we go. Beautiful. So we've gone from an equation to a graph of the equation. Much easier to reason about later and to see patterns than just the equation. Good, I hope this has helped. And yeah, good luck with the questions and getting some practice. Bye everyone.